In this section, we're going to introduce the serverless computing, serverless services that Amazon Web Services provides. These are the services that we're going to focus on for this course. There are other ones, but typically the types of architectures and applications built with serverless use these services quite often. We're going to review these one by one and give you an overview of what they're for, why would you use them, and how you could use it to build an application. So on the AWS website, they have a whole section focused on serverless computing. The purpose of serverless, when it was branded that, was to help you focus on delivering outcomes rather than focusing on servers. With servers, you have to install the operating system, you have to install any runtime applications, like if you're running PHP or Node, JavaScript, Python. There's also the web server aspect, the database server aspect, the cybersecurity where you harden it to avoid a hacker breaking into your server. There's a lot to it. With serverless, the whole thought is you use a service or you upload your code and you don't have to worry so much about all the configuration that goes around a server. You just, if you need code to run, you upload the code, it runs. AWS takes care of the rest of how to run it, how to secure where it's running, and they just deliver, they run the code and deliver the output. So here's some of the services they highlight on this page. There's AWS Lambda and Fargate. So Lambda is where you upload your code and it'll run that code. The underlying technology is probably what is called a container, which is a really small computer that's running virtually. It turns on, does what it needs to, and turns off. It's hidden from us. We don't know exactly how AWS does it, though containers is what we're informed of what it tends to do, because you can configure the container. How it's organized, we don't have much control over that. Fargate, they does use the container service. You can use their ECS, Amazon Elastic Container Service, or you can use Kubernetes, which is a popular container software. So that's how you run code. Now, when you want to integrate your application, you have different services. So Amazon Event Bridge will send what are events. You can receive an event and you can send it somewhere else. So an event is really just code or text that has information and it comes in to Event Bridge, and then you can have it forwarded to another thing like a server, a web application, a third-party service, a Lambda function. Step functions allows you to create different Lambda functions and organize them in a logical order. It's kind of like creating a flow diagram in Visio, and imagine each Visio element runs some piece of code. SQS, the simple queue service, it's similar to Event Bridge, where it gets an event and it holds it in a queue until something requests for the message, processes it, and tells the queue, okay, I'm done with it. Whereas Event Bridge takes it and forwards it. SNS is a very simple version of Event Bridge. It can be used to forward events. It can also be used to send push notifications or text messages to end users. API Gateway has what is an application programming interface. So it's an HTTPS web address where you can send a data and it'll respond, give some kind of response. So that's how you build the backend for the front end of a website or a mobile app. AppSync is a way of getting data from a database. There's different ways of storing data. We're mainly going to focus on S3 and DynamoDB. These other ones are really good, but these are the lowest barrier to entry. S3 is blob storage, and DynamoDB is a serverless NoSQL. So you can't do SQL queries. It's a different format. It's more like big data tables. All right, so here's an example architecture to build a web application. As you see, you can organize Lambda functions, Cognito, identity provider service, DynamoDB here to store data. This is the API. So let's jump into each service a little in more depth. So Lambda, it's for computing, it's for running code, and it runs on some kind of container technology that's hidden to us. We don't need to configure how the container runs, but we can specify what type of container, like if we want Node, JavaScript, Python, Java, for example. So as you pay as you go, so you define how much CPU and RAM you need, depending on how computation intensive your code is. Then you can upload your code and it'll run, and you'll be billed for the amount of seconds and the amount of compute it does based on a pricing table. So here's some examples of how to use Lambda. You can, let's say you upload a file into an S3 bucket, and then you can tell the S3 bucket to trigger a Lambda function. The Lambda function will then run code to resize that image, and it can then store that image back into the same S3 bucket or a different one, but now it's different sizes for different devices that are viewing the photograph. So you have a website that's running serverless. It needs to get data, so you use this API gateway for the API, and then here the API will then forward that event request from the HTTP connection to a Lambda function that processes the event, and then if it needs to get data, it will get data from Amazon DynamoDB, which is our serverless database, and then it'll send the data back to the API, and then the website will then use that data as appropriate. You can do the same kind of thing with a mobile backend. Instead of a website, you have a mobile app. That's Lambda overview. Now let's go to API Gateway. You can do what is called a RESTful API. That's typical HTTPS using the HTTP methods such as get, post, put, delete. And then you can define what the endpoints are. So you could be like api.mydomain.com/books. And if it's a get method, the /books endpoint will return the list of books. If it's the /books is a post method, it will then update the book list and add a new one, for example. WebSocket APIs uses the WebSocket technology. So it has an active connection from the website to the API that's constantly going. So rather than having to do a constant HTTP request, it already has an active connection and it can send messages back and forth. So how does it work? Like we mentioned, you can have a website or a mobile app. You can have IoT devices. Anything that needs to send message to a backend, it'll send the HTTP request to the API gateway, and then the API gateway is configured. If it has caching enabled, it can just send a cache response to save on processing. But if it's not a cache response, it can then forward the request to a different endpoint like Lambda or Kinesis, server on EC2, directly to DynamoDB, etc. There's many ways you can configure this. This is a serverless technology because if nothing makes an API request to the API gateway, it doesn't do anything. You'll only be charged for what you use. It's very on demand. So the next one is S3. This is probably the simplest way to get into serverless. S3 is what is called object storage, or you may have heard the term blob storage. It can hold data of any type. It can be text, it can be image, it can be a file that's gigabytes big, like a backup drive, whatever you need it to be. It just stores objects, and it's not specific to what the object is. It's not like a file storage where the file has to conform to the file format and you can't search it like a file storage. So S3, the storage is really a key value storage. So you have a key that defines what the file, how you find the file, and then the value is the data of the file, so text, image, base64 encoding, whatever it is. So again, you pay for what you need. It essentially almost infinite storage. You have limitations on how big the file can be, but it's like really big. And then you also have a limitation on the number of objects, and again, that's really big. Actually, no, you have a limitation on the number of buckets, but the number of objects within a bucket is unlimited. So what is a bucket? A bucket is essentially a storage location. You can think of it as a file server, and each bucket is like its own file server, and you can, if you only have access to the first bucket and not the second bucket, you can only get the data that's on the first bucket, and then anything you put in there is called an object. So you can use it for many different things: to back up and restore data, to archive data, to use generative AI so it has data for it to do its training. We're going to be using it to create our front-end website. We're going to put our website files up there and then turn on the web server feature in S3 so you can show up as a website. We're going to combine S3 with CloudFront. These two things together provide the web server functionality. CloudFront is called a Content Delivery Network, or a CDN. What it does is it caches copies of the website files at various routers throughout the world, bringing it closer to the user. So when I go to a website and I type in the address on the address bar in the browser, it'll try to get the file, but rather than having to go all the way to where the server is, so let's say you're a user in California and you chose an AWS server in North Virginia, the packet would have to travel all the way to North Virginia, get the data, get the HTML files, and send it right back. So that's over 6,000 miles that it has to travel. But with CDNs, it could be a copy of it cached or stored locally at a router, let's say in Northern California. So it would only go as far as Northern California and back to Southern California to get the file. So that's a much faster delivery time. So here's essentially what I just described. The end user goes to the nearest location and retrieves that. You can also run Lambda functions in CloudFront to modify certain properties like the headers or the data that's in the request. That gives you additional functionality. It's very limited execution than a typical Lambda function, where a Lambda function can run almost any workload. The Lambda Edge is very specific function just to modify the request or the response. So DynamoDB, this is the serverless database we're going to focus on. It's no SQL, so it's also a key value database. It's also on demand, or you can provision, so you can decide that within any given hour, I need to write so many kilobytes of data and read so many kilobytes of data and have it guaranteed. Or you can pay a higher cost for read and write if it's on demand. Choosing the provisioned or the on demand really depends on how much traffic you get. If your traffic is on and off and it's not very consistent, then probably it's not worth paying for provision throughput. But if you're consistently getting a gigabyte worth of requests every hour, when you plot it out, it almost looks like a bar. It's very consistently within a range, and then at that point you might consider doing provisioned. So it's really fast. It's a serverless. So if the data is just sitting there, you just pay for the data storage. You don't need to pay for reading and writing if you're using on demand. So here's how it works. You create a table and then you define your schema for the table. So a primary key and then what is called a sort key. So the primary key is essentially the index. You can have entries with the same index if they have a different sort key if you define the sort key. If you provide both the primary key and the sort key while you're searching, then you can get that specific entry. But if you just need the data for that primary key, then you'll get, let's say there was 10 entries with each with its different sort key, then you would get those 10. CloudWatch is a service that goes well with serverless. It provides logging, monitoring, alerting. So if you so when you're writing your Lambda functions and you write a log entry using print, for example, with Python, or console.log with JavaScript, that gets written to a CloudWatch log that you can use to look at your code execution. You can start logging errors, and then you can run a Lambda function or some kind of workload to look for how many errors are being written, and you can monitor that over time. There's also built-in metrics that CloudWatch has. You can, let's say, monitor on the number of 500 HTTP errors that you get on your API gateway, and if it exceeds a certain amount, then you can have an alarm that sends a notification to your team letting you know, oh, there's an excess of 500 errors that's unexpected. Maybe that could be an indicator that there's a bug in the code or something broke. Simple email service, SES, allows you to send emails. What you do is you make an API request to the SES API, and you can have it send an email from your application. So let's say you want to send an email to a user whenever they buy something from your website or they log in. You can use a Lambda function to make that API request to SES, and it'll send an email to that user SNS allows you to do push notifications, and it also allows you to send messages. So let's say you want to, on a periodic basis, you have, let's say, a Lambda function that's looking for an entry in a database on DynamoDB table, and it finds, let's say, records that are flagged with unprocessed. You can have the Lambda function send those 10 record IDs to an SNS topic. A topic is really a set of messages that you want to be sent out, and anyone that subscribes to that topic will get the message. So it could be, let's say, if you're doing it manually, you send those database IDs to a team that's looking for emails. So you would have it sent an email with those IDs, and then the team will read the email and process those IDs. It could be sent to another Lambda function that's only processing events from SNS, and it's processing those entries based on the database ID. There's very different configurations. That's one way to do orchestration or architect your application. You can also use it to send text messages or push notifications to mobile apps that subscribe to that SNS topic. Cognito is Amazon's identity provider solution for your application. It allows you to create users, have them log in with a password or passwordless. You can have them configure multi-factor authentication to protect their account with the Authenticator app or a text message. So what happens is you integrate your Cognito application, you define how you want users to sign up, how you want them to sign in, and what information you want the users to provide, and then how they access it. So they can, let's say they can log in through Google or with an Apple ID, or you can have them use a security key. And then once the user signs in, it'll create an access token, which the application can then use to verify that that user is successfully logged in. In this section, we'll review the AWS Certificate Manager, or ACM for short. ACM allows us to create SSL and TLS certificates. This comes in handy when we need to have a certificate when we have an HTTPS custom endpoint. For example, we might have a custom domain for a CloudFront distribution or an API gateway. The browser or the web application will need to verify that the HTTPS address has a valid certificate. So when we create a custom domain for CloudFront distribution or API gateway, we will need to specify the TLS certificate. We can do this by pointing to the ACM certificate that we've created. As you can see, there are some benefits and use cases for using ACM. To me, the biggest benefit of ACM is the certificate renewal process. When we use AWS's Route 53 DNS service, ACM will automatically verify the certificate by communicating with Route 53. Every certificate we create in ACM will expire automatically after a year. We will need to renew it manually every year if we are not using Route 53. We will cover Route 53 in the next section. In this section, we will review Amazon Route 53. Route 53 is a DNS service. It's completely cloud-based. It allows us to create what is called hosted zones for DNS domains. We can create a hosted zone for a top-level domain or a subdomain. Route 53 has very advanced features, as you can see in the benefits listed here. To me, one main benefit of Route 53 is the simplification of creating custom domains and registering DNS records in our DNS service. We will primarily use Route 53 as our DNS rather than an external DNS service from another domain provider. By doing this, we can provide a consistent development experience. We can even use Route 53 to purchase a domain. Lastly, this is the Identity and Access Management, or IAM. This is how AWS gives permissions to resources to access other resources. For example, if I have a Lambda function and I want to get data from an S3 bucket, I have in my code the API request to S3 to get an object. It'll deny me because by default, resources don't have access to other resources. So what will happen is you need to create an IAM policy that says for this bucket, you are allowed to get any object or maybe objects that start with a certain prefix. Now then you assign that policy to a role, and the role is what the resource gets. So the Lambda function will be assigned that role, role, and that role has a policy that says it's allowed to get an object from a specific bucket. You can also use it to authenticate users into your AWS account. We'll mainly be focusing on how to use IAM for the serverless application. And that's the overview of serverless.